In this segment, we are going to be exploring another property of exponents called the quotient rule. Now, quotient just means divide, so we're going to be looking at what happens to the exponents whenever you divide the power. So for starters, let's do x to the 5th power divided by x to the 3rd power. So let's write this whole thing out. X to the 5th power means x times x times x times x times x. X to the 3rd power means x times x times x. So we've learned in past units that when you divide, things cancel out. So like right here, x divided by x, anything divided by itself is 1, cancels out. All right, here x divided by x, anything divided by itself is 1, it cancels out. And then here, anything divided by itself cancels out. Notice that we have nothing left on the bottom, so there's nothing else we can cancel out. All we have are 2 x's left over. X times x can be written as x squared. Now, how do you get from the start to the finish here? Well, x to the 5th power divided by x to the 3rd power, you could just do 5 minus 3 to end up with 2. That is the quotient rule. Quotient rule says that when you divide any power with the same base, all you do is subtract the exponents. So on division problems, you subtract the exponents. So let's try this next example. Down here at the bottom, we've got x to the 5th power, y to the 2nd power, divided by x to the 2nd power, y. Now, think about the x's separate from the y's. X to the 5th power divided by x to the 2nd power would be x to the 3rd power, because 5 minus 2 is 3. And now for the y's. Y squared divided by y. Now on the bottom there's only one y written. If you want to put the exponent, you can. Y squared divided by y would be 1y. 2 minus 1 is 1y left over. And that would be our final answer. Okay, so again, the quotient rule, when you have a division problem, you subtract the exponents. The only problem is these two numbers, the 8 and the 2, those aren't exponents, those are coefficients. So this just says 8 divided by 2. 8 divided by 2 is 4. Okay, now think about the x's. X cubed divided by x. This is 1x down here. X cubed divided by x would be x squared, because 3 minus 1 is 2. And the y's, y to the 7th power divided by y to the 4th power would be y to the 3rd power, because 7 minus 4 is 3. And our last example here for the quotient rule, we have 3x to the 4th power, y to the 5th power, divided by 12x to the 4th power, y to the 2nd power. Okay, so let's start with our numbers. Remember, these are not exponents. This literally says 3 divided by 12. 3 over 12 can be simplified to 1/4. And then if you look at the x's, x to the 4th power divided by x to the 4th power. Well, it's the exact same thing. Anything divided by itself cancels out, right? 4 minus 4 is 0, so there's no x's left. And then the y's, y to the 5th power divided by y to the 2nd power would be y to the 3rd power, because 5 minus 2 is 3. So your answer could be written like this. Your answer could also be written as a single fraction with y cubed on top and the 4 on bottom. Either way would be acceptable. Now, there is an extension of the quotient rule that involves negative exponents. So we're going to revisit this example of our lesson with x to the 5th divided by x to the 3rd power. We said 5 minus 3 is 2. But what if the whole fraction was reversed? What if you had x cubed divided by x to the 5th power? If you subtract the exponents, 3 minus 5 would be a negative 2. But what does that even mean if you have a negative exponent? Think about the way this problem would be written down. X cubed would be x times x times x, and x to the 5th power would be x times x times x x times x times x. And of course, with any division problem, you want to cancel things out. X divided by x cancels out. X divided by x cancels out. X divided by x cancels out. And you're left on the bottom with x squared. There's two x's left. So x times x is x squared. Now, there's nothing left on top, but you don't leave it blank. You put a 1, right? Because as we're dividing this stuff, anything divided by itself is 1. So if there's nothing left on top, that means you divided everything out, you're left with a 1 on top. This is what your negative exponent represents. Okay? So when you have x to the negative second power, all that means is, hey, it's x squared, but it should be written on the bottom. Okay, so a negative exponent should always be moved to the other side of the fraction. So let's try a couple of those. Okay, x to the negative 8th power. X to the negative 8th power, the negative exponent tells me it should be written on the other side of the fraction, so that would really just be x to the 8th power down on the bottom. There's nothing to put on top, you would just put a 1. Okay. For the next one, you have 5x to the negative 2nd power. That negative exponent tells you that the x should be written on the bottom. So when you move it to the bottom, it would be x to the 2nd power. Now, I do need a number to go on top here. That's where that 5 comes in. That 5 is still there, so it would be 5 over x squared. So again, the negative exponent just tells you that it should be written on the other side of the fraction. Okay, and on the last example, we have 6 over x to the negative 3rd power. A negative exponent tells you it should be written on the other side of the fraction. So this whole thing shouldn't be written on the bottom. It should be written on the top with the 6. So this should really just be 6x to the 3rd power. So if you ever end up with a negative exponent, you have to take the part with the exponent and move it to the other side of the fraction. If you have a negative exponent on the bottom, you got to move it to the top. If you have a negative exponent on the top, you got to move it to the bottom.